Hello and good morning, everybody. Today I want to explain to you just how to convert SolidWorks sketch to URDF, that we are going to use it in our programming in robotic operating system. So I face a lot of difficulties in this manner. These kind of difficulties, it is the axis selection and also the plane selection that we are gonna sketch on them, because URDF plugin in SolidWorks, they require exact and specified features and specified properties that we have to follow them like constraint. If we don't follow them, the SolidWorks sketch cannot be converted very smoothly and very quietly. So I want to explain to you how to get rid of these kind of difficulties. Firstly, as you know, we have to install the plugin from ROS website, and it will after install it will appear here like export as URDF. So after that, after we install it, we can click on it. But firstly, let me explain to you. When we sketch the part, we have to sketch them on top plane. Okay, top plane. Every sketch, it has to be in top plane. This is the first link, next link, and also the second link, that's the third link. All of them must be sketched on top plane. Okay, because SolidWorks plugin or URDF plugin, it requires like that. And also the origin must be start from the revolute joint. You know this is the origin. I can show it from here. This is the origin. It is the first origin, it is in the starting point. The second origin, it is starting from the first revolute joint. Third origin is start from the second revolute joint, and the fourth origin is start from the third revolute joint, and is going like that. After we sketch and also assemble all the parts, so we can go one step further, and from the tool export as a URDF, and then one window will appear to us. So this is the base link. We have to select it from here, and then base link is already named, and then we can click from here, incremented by one, second link, and we have to change it as we like. Link, for example, number one, and the joint, we can give it joint 0 or something like that. From here we can select it as a revolute joint. Then we can go to the second, incremented by one, second link. Okay, and we call it link number. Just let me. No, we have to delete this one. We can go to the second link. This first link is selected. Second link, we can select it and write it like here, link number 2, and then joint number 1, and then we have to select it as a revolute joint. So it is already okay. And then we increment it by 1. Okay. Link number 3. Link number 3, and joint, for example, number 2, and the joint type, it is a revolute joint, and then increment it by 1, 2. Okay, and we have to name it as link number 4, joint 3, and as a revolute joint. And we, to be sure, we have to go one by one. Okay, link 3, link 2, link 1, base link, everything is okay. The joints, links, and everything is okay. Then one step further, it is load configuration and also preview. Don't press on it on this one. Okay, we have to press preview and export. Okay, this preview and export. Now you know the axis is installed automatically, because we selected from there automatically. If we don't sketch them in the exact place, so the axis will be randomly placed in the wrong place. So but now it is placed in it is placed in a good and specified place. And then we go one for the, I don't know if it is appear here. Just a minute. And now this screen appears to us, so we have to go step by step. This is, for example, the joint number 3, no, joint number 1, joint number 2, and like this. So we have to select the type of joint to revolute, and we, for example, we need to specify the limitation of the revolute joint. For example, 0.1, 1.80 radian. The upper limit is, for example, 1.80. Here the effort of torque, it is 10 Newton meter. Velocity, let us select it by the 100 radian per second, and let us just make it for all joint the same, like 0.1.8, 1.8, 10, 100. Go step by step like this. 1.8 minus, and here 1.8, 10, 100. Go to the joint number 0, 1.8, 1.8, 10, and also 100. Then click next. Now the length is also already defined automatically. Then export and meshes. Okay. Then we have to, for example, come to the desktop and make it as AIBO Mech robot. Give it any name, like here, robot, my robot. Okay. Then store it inside it. Okay. If we come to our screen, we can see, this is axis, and we can see, axis is placed, all axis is placed, and we can already take our file to ROS, and I will explain it in other video. How can we demonstrate it on RVs and also on Gazebo. Thank you so much and have a good day. I hope that this video will be benefit for you, and don't forget to share it with those who are interested with ROS, robotic operating system.